Welcome to Java EE6 webinar series from jpassion.com. Today's topic is Servlet 3.0 Advanced. So we have covered basic features of Servlet 3.0 in the beginning of this course, the topic number 2 right here. And we are going to cover some advanced features of Servlet 3.0, especially asynchronous Servlet and some security. By the way, the next webinar is going to be in January. It's going to be January 9th. So we will have a few weeks break. Okay, so let's start with a presentation. So here, the two major topics that we are going to cover. Servlet 3.0 async support, and then security enhancements. And then if you have time, we'll cover some miscellaneous features. So let's talk about Servlet 3.0 async support. Now, before we actually delve into Servlet 3.0 async support, let's talk about why this async support is important on this web application, the Servlet environment. So let's talk about some technical background a bit first. Now, one of the technical background we'd like to understand is the web server scalability and performance evolution phases. So, we'll talk about each of this, and as you can see, async servlet is in fact the last evolution phase for providing performance, high performance, and scalability. So, in the beginning, we have HTTP 1.0, and then we moved to HTTP 1.1. And then we have a concept of thread for connection and thread for request. And each of these has some issues, even though this one provides a better performance and scalability than this one. And this one provides a better request. Thread for request provides the better scalability and performance over thread for connection. Each one still has some issues. So that's the reason we finally have what is called the async servlet. So let's talk about each of these in a bit more detail. So HTTP 1.0 has some issues. In HTTP 1.0, a connection between a client and server is closed after a single request and response cycle as a default. And of course, if you are sending multiple requests and if you're having multiple request and response cycles with a server, that's inefficient. So in HTTP 1.1, connection is kept alive and is reused for multiple requests and responses as a default. So this is called the persistent connections. So this provides better performance, of course, because a client does not have to recreate TCP connection every time it has to send a request. So HTTP 1.1 certainly provides a better performance. Now, on the server side, we had what is called the thread for connection. So what it means is that it's used to enhance the scalability for web servers, and it's based on HTTP 1.1's persistent connections. What it means is that each persistent HTTP connection between the client and server is tied up with a single thread on the server side. And these threads are allocated from server-managed thread pool. Now, once the connection is closed, then that dedicated thread is recycled back to the pool and is ready to serve other tasks. That sounds good. However, there is still some issues from scalability standpoint. So let's say you have X number of threads, and this X number of threads can handle only X number of connections. Now, for many websites, the user request pages, clients actually request pages from the server only sporadically, which means the connections are staying up between this request. And while this connection is being tied up, the server thread is also tied up. So this is a waste of thread resource on the server side, and this is causing scalability problem. By the way, a thread is actually pretty precious resource on the server side. Okay, so in this case, for X number of threads has to be tied up for X number of connections, even though each connection is not being used, all the time, because between the request there is actually idle time, and at that point, the thread is still being tied up with the connection because connection is still up. So next, so the solution to that problem is thread per request. So instead of actually tying up a thread per connection, now we want to tie up a thread per request so that we do not have to waste the thread resource between the requests, meaning when the connection is up there. So this is actually in fact supported in Java SE5's non-blocking I/O capability. So persist in this case by leveraging non-blocking I/O capability introduced in Java 4's I/O NIO package. A persistent HTTP connection doesn't require a thread all the time. Okay, so basically threads get allocated to connections only when requests are being processed. So when a connection is idle between the requests, the thread can be recycled. Okay. And then the connection is placed in the centralized NIO select set to detect new requests. So whenever there is actually new requests coming in, that's the time the thread will be allocated from the pool. So this model is called the thread per request, and it potentially allows web servers to handle larger number of user connections with a fixed number of threads. So if you compare thread per request versus thread per connection, here you are dealing with you have X number of threads can handle only X number of connections, okay, from clients. Here, thread per request, you can handle a lot more connections with X number of threads because threads are not tied up with number of connections all the time. Okay, so it solves the problem, scalability problem of thread per connection that we just talked about in the previous slide. Okay. All right, so that's cool. In fact, the thread per request is being supported by most web servers. So, the Tomcat, Jetty, Glassfish, pretty much all the web servers out there, they are taking advantage of Java, the NIO to handle, to handle the request using thread per request model. So, you get this thread per request model implementation from the server, so you don't really have to worry about it as a developer, by the way. Now, that's cool. Now, there are other developments that actually impact the scalability and performance, Ajax. So Ajax enabled clients send more requests to the server because it sends a request whenever it needs to access the data from the server. So it basically increased the traffic between client and server. So it is a factor for new scalability problem. Now, this is actually a big one. Threads are accessing slow responding resources. So, so you got the new request, the server got the new request from the client. And if the request involves accessing remote resources, for example, web services or databases, and then that thread is being tied up to handle the access of those remote resources. So threads that handle these slow serving requests could be waiting for the responses coming from those remote resources. Okay, so for example, the thread is assigned for that request, and if that request involves accessing database, of course, accessing database is a very slow process, and until the database returns, the thread is tied up. Okay, so again, we have a situation, even though we are using thread per request model, as we talked about here, we still have a problem when the request involves accessing remote resources. Okay, which means in that case, the thread is again being tied up until the remote resources send back the response. So we need a better solution to this. So what we want to do is we want to recycle the threads that are waiting for a response from these remote resources, again by placing the request in a centralized queue waiting for available resources and release the thread. So basically, when the request involves accessing remote resources, which is very slow, we want to recycle that thread. Okay, so that's basically what Servlet async support is all about. Okay. So this basically shows Servlet 2.5 where thread is being blocked when it is accessing remote resources. This could be a database or this could be a web service. So, request is received from the client. A thread is assigned, and then thread is going to invoke remote resource, and during this time, until this remote resource is actually responding, thread is blocked. Same thing here. By using async support in Servlet 3, when it actually accesses the remote resource, at that point, you can release the thread. So the thread can be recycled. Now, when the remote resource is sending back the response, that's the time the new thread is being assigned from the thread pool to handle the response from the server. So this is what the async support in Servlet 3 is all about. All right, so basically idling thread impacts scalability. Okay, so as I mentioned before, thread is a very expensive resource on the server side, and you want to take advantage of, you want to actually leverage the usage of a thread as much as you can. So this is basically giving you an example why the idling thread impacts the scalability. So let's say you have a web application accessing remote web service handling 1,000 requests per second, and 50% of this request called remote web service, which is a very slow process. And then you have, and let's assume you have only 500 threads in container thread pool. So if this remote service is slow, it takes about 1,000 milliseconds, which is 1 second. Then thread starvation happens in 1 second. Okay. At that point, the users will experience the very slow responses from the server, because the threads are basically, the threads are gone. There are not any thread that can handle those requests. Okay. So basically, this is if you actually see the evolution, if you see the evolution of the thread per connection, thread per request, and async servlet. Basically, all these ideas is to remove the idling time of the thread and to take advantage of the thread to use the thread to its fullest extent. Okay. All right. So hopefully you got some sense of what the async support is all about. Now, when we say examples of remote resources, obviously web services or databases, those are, the two primary examples of the remote resources that is taking a lot of long time to actually, to invoke and get a response. Another example is the event. Okay, so you could in fact have a chatting application, and your application is waiting for the next chat message from someone. That could be again another example of a very long remote resource. Okay, so basically at that point again, thread could be waiting for this chat message to be to be delivered from somewhere. Okay, so that could be another usage model, another example where this async servlet could be actually very useful. All right, so this is an example code, and so basically you are going to create what is called the async servlet object. So basically, by the way, you have to specify you have to specify this servlet supports the async by using async supported to equals true. Okay, so this is the way that you are indicating this servlet is async servlet. Okay, so when async support servlet supported servlet async supported attribute is set to true, the response object is not committed on method exit. What it means is that when this servlet is declared as the async servlet, response object does not have to be sent back to the client. Okay. Now, so in this case, the way that you are going to implement async the servlet is basically from the request object, we are going to call start async method. And what you get back is what is called the async context object. You can think of this async context object, okay, is an object that contains this request and response. So later on, when response is supposed to be sent back to the client, this async context provides all the information. It has all the necessary pieces that response could be actually sent back to the client. Okay, so I want to actually read this one more time. Calling start async returns async context object that caches the request and response object pair. So this is what I meant. This async context object maintains the original request and response object. Okay. And this async context object is then stored in application scope queue somewhere. You could actually save it any place. Okay, it doesn't have to be in a queue. Okay, this is actually from the code of chatting application. So that's the reason that we have actually a queue for all these all these async context object from different clients. Okay. Later on, this async context object is retrieved by another thread to send back the response to the client. Okay. So here in this code, typically if it is not async supported servlet, then do get is going to send back the response, right? But if it is the async servlet, then there is no need to send back the response. Okay, so without any delay, do get method returns. So do get doesn't have to wait until remote resources to send back the response. Instead, it will just return. Okay, all right. We're gonna actually see some more examples in a few minutes. All right, so let's talk about, so one of the usage of the servlet async, async servlet is what is called server-side push or comet or reverse Ajax kind of things, okay? So let me actually talk about this server-side push or reverse Ajax or comet a bit, and then we'll see how async servlet can be in fact used to support this comet or reverse Ajax or the server-side push. Now, what is server-side push? Well, what is comet? The first generation Ajax is not asynchronous enough. So first generation Ajax is basically providing async support from the client to the server. Okay, so that client does not have to actually wait for the response from the server. Instead, client can actually continue the processing. Okay, however, it handles only one side, meaning it handles the one side asynchronicity from the client and server. The other part of the asynchronicity we want is that we want the server to be able to send back things to the client whenever it wants to. Okay, so full asynchronicity includes updates pushed from the server to the client at any time. So this is basically server-driven page update. Okay, so in first generation Ajax, when it actually handles only client side, the server still has to wait until the client polls the server. Okay, so we'll talk about that in a few minutes in a bit more detail. So it allows users to communicate and collaborate within the web application. And this server-side push is called sometimes Comet or Ajax push or reverse Ajax. So this reverse Ajax or server-side push could be used in many different type of application. For example, like a distance learning. So whenever a teacher changes the slide, everyone actually see the slide right away. Okay, or collaborative authoring or auctions. So again, the collaborative authoring, whenever everybody actually change the document, you want everybody else actually see the change right away. Auctions like eBay, whenever someone outbids you, you want to actually get the that outbid information right away instead of you polling it, to find out there has been a new bid. Okay. All right, so I'm gonna actually move on to the next slide. So Comet or Ajax push is basically providing it's a programming technique that enables web servers to send data to the client without having any need for the client to request for it. Meaning, the client doesn't have to poll it. Instead, the server should be able to send the data to the client whenever it actually has interesting event or data. Okay. So it provides a highly responsive and event-driven web application, like a chatting application or auction application or distance learning application, because it keeps clients up to date with the data from the server. Okay. So advantage, of course, is a low latency and it's not dependent on polling frequency. Okay, we'll talk about that in a bit more detail in the following slide. And the server and network do not have to deal with the frequent polling requests to check for the update. Now this, the one last item I'd like to actually mention is in HTML5, this is actually being supported natively through what is called the WebSockets, okay? Excuse me. All right, so this is basically the Ajax versus Comet. So reverse Ajax. So the first, this is actually the original Ajax, one-side Ajax, and then these two, Ajax push or Ajax push, these two, second and third, they are server-side push. So in the one side Ajax, the browser has to poll the server to find out if there is anything interesting data from the server. Okay, so in the first time here, request is sent from the browser to find out whether any interesting data, and the server says, oh, I don't have any interesting data, and then the server receives some interesting data as an event here, and this time from this event, the next time a browser polls, this is a latency. This is the time that client has to wait, okay, until it sends the next polling request. The client has to wait, okay. Now, in Ajax push or reverse Ajax, in fact, of this long poll, the second model is the most popular reverse Ajax model. In this case, browser send the request to the server, okay? And until there is interesting data on the server side, the response is not going to be sent to the client. Okay? So when there is actually interesting data on the server, then that's the time the server will send the response back to the client. Client received the data and then it will send the request right away. So this request will not be responded until again interesting event happens. Okay? The second scheme of this reverse Ajax is browser send the request and the server send back the response whenever it received the interesting data. So it actually sends the response in multi-part fashion. Okay. Now this long poll is actually a lot more popular. The reason is because, let me actually move on to the next slide. So the first scheme, this first scheme is poll. Okay, so in this case, poll is that send the request to the server every X seconds, and response is empty if there is no update. The long poll, so this is the most popular model. So client sends the request to the server waits for an event to happen, then sends the response. The response is never empty. Now, there is no client-side hack needed, okay? Because as far as the client is concerned, the server is just behaving as a slow server. Now, in HTTP string model, in this third model, the client needs to be changed. The reason this long poll scheme is a lot more popular is because the client does not have to change. Okay, the server just happens to be a slow server. In this case, this one, you need to change the client code. That's the reason this is not popular. Instead, this long poll reverse Ajax model is popular. All right, so that is actually basic, background information on what is called the reverse Ajax and the Ajax push, and we'll see how this servlet async is being support to support this server-side push or in reverse Ajax. All right, so before Servlet 3.0, meaning before async servlet is actually being supported, all the server implementation, they obviously want to take advantage of this, the scheme that I just mentioned. Okay, so what I mean is the feature that is supported by Servlet 3.0. So the server implementation, even though there is no servlet standard, all the servers actually have their own implementations that provide similar functionality like a servlet, async servlet. Okay, so Tomcat has a comet processor, Jetty6 has a continuations, and Glassfish has what is called the comet engine. Okay, so these are proprietary implementation of async servlet, if you will. Okay, so these are proprietary classes and interfaces. And of course, that's not, the applications are portable. Applications are not portable. That's the reason we need a standard-based support. So that's the async support in Servlet 3.0 is all about. So async servlet API in Servlet